In this video, we look at some of the features of an operating system in a little bit more detail. In the previous video in this topic, we looked at a range of user interfaces: graphical, command line, menu driven and natural language. Refer back to that video because user interfaces are an important feature of operating systems. But in this video, we're going to look at some of the more technical aspects of operating systems. One of the features of modern operating systems is something called multitasking. This is where you have more than one program open and running at the same time. Now, they're not really technically running at exactly the same time. The processor is allocating a small amount of time to each process, but it happens so quickly it feels like they're actually executing simultaneously. So let's look at a typical example. Here we have a word processor and it's had a document open, but that's not the only program that our computer has open. Perhaps you're also doing some research on the web using your web browser. Perhaps as you're working, you're also listening to some music that's being played by a media player in the background. You might well also have antivirus software that's preventing viruses from coming down from the internet and infecting your computer. The clock is also updating in the corner of your screen, and the operating system itself is engaging in a number of maintenance tasks in the background as you're using the computer. So it appears that all these applications are running at the same time, but they're not. The word processor has a small time slice, and then it's passed to the web browser that has a small time slice. That's passed to the music player that has a small time slice, then to the antivirus, then to the clock, and then back to the word processor again. But your computer executes these instructions so quickly that as a user, you don't really notice that it's actually switching tasks. This is what we call multitasking. Now, in order to manage multitasking, the operating system also has to manage the memory very carefully. So when a program is loaded from the hard disk, it's put into a specific place in the RAM, decided by the operating system. Here in this illustration, we can see two orange squares representing the size of a program that's just been loaded into the RAM. Another smaller program gets loaded, represented by the purple square. The user now may choose to close the first program, so here we can see the orange squares have disappeared. Now, in reality, nothing is really erased from memory, but the illustration shows that those memory locations are no longer being used by that application, and so they are essentially marked as free and available for reuse. The user may then choose to open a third program, represented here by the green squares. This third program is bigger than the previous two, but you'll notice because the second purple program is taking up a space in memory already, it's not simply shifted around because that would be very slow and intensive. It stays where it is and the green program fits around it. So over time, the memory becomes fragmented, and the operating system has to manage these fragments of programs across the entire memory. In addition to this, when you save or load a program, or when you interact with the operating system, when you use your keyboard or mouse, or if you print a piece of work or display something on the screen, the computer has to be able to output to all of these various devices. If we think about printers specifically, although the document you want to print will be the same, and you expect it to look the same no matter what type of printer you're actually printing it to, the technology behind each printer can vary wildly. If you've got an inkjet printer, it's spraying droplets of ink onto the page. If you've got a laser printer, then it's magnetizing areas of the page and using toner to fuse to the page in order to produce the output. And the plotter is going to use a pen to draw across the page. So there are three very different technologies to produce what could essentially be exactly the same output. and therefore a device driver is needed to translate the operating system instructions to print into a series of instructions that that particular piece of hardware is going to understand. And this is the purpose of a device driver. So let's just recap these three tasks that operating systems perform that we went through in this video. Multitasking, the running of multiple applications at the same time by giving each application a small time slice of the processor. This allows more than one program to be held in memory at a time and data shared between them, such as copy and paste. It also enables you to listen to music on your PC while performing other tasks such as word processing. Memory management. When programs are loaded, the operating system decides where they're held in memory. Over time, the memory becomes fragmented as programs are loaded and closed because they use different amounts of memory. The operating system must keep track of different program fragments, and when the memory is full, the operating system uses virtual memory. And device drivers. Translates operating system instructions into commands that the hardware will understand. Each peripheral needs its own device driver, and many are already built into the operating system.